This video is about midpoints and distance in the coordinate plane, and it corresponds with our textbook in section 1-7. I want to begin by talking about the average of two numbers. Now we know how to find the average of two numbers like 20 and 40 by adding them together and dividing by 2. So 20 plus 40 divided by 2 is, let's see here, 20 plus 40 is 60 over 2 is equal to 30. Now the reason why that's important is because 30 is right in between 20 and 40. So on my number line, if this is 20 and this is 40, the number right in between them is 30. So finding the average will give us the number that's right in the middle, which is the idea of finding the midpoint in one dimension. So this is a formula that may or may not be super useful to us, but it's an important building block for us as we move to two dimensions. So the way you find the midpoint in one dimension is by adding the coordinates together and dividing by 2. So for example, segment AB has endpoints at -4 and 9. What is the coordinate of its midpoint? Well, I take the two numbers, I add them together and divide by 2. So -4 plus 9 divided by 2. -4 plus 9 is 5. 5 divided by 2 is 2.5. So 2.5 must be the coordinate that's right in the middle, which is about right here, which looks like to be in the middle. Okay? Now that's how you find the midpoint in one dimension. Let's move now to two dimensions, and I have this point right here and this point right here. Okay? And all we're doing is finding the midpoint of the change in x's and the midpoint of the change in y's. And that'll give us the overall midpoint between the two lines. Okay, so here's the formula. This one is super important. You absolutely have to have these in your notes. Okay, but all you're doing is finding the average of the x's and the average of the y's. Okay, it's that simple. Okay, make sure you have these in your notes. Moving on. Okay, let's do an example. I have 2 points, the point -2, -2, and the point 4, 0. And I'm going to find the point that's right in the middle of them. All I'll do is find the average of the x's and the average of the y's. So first, -2 and 4. Now the order here doesn't really matter because I'm adding them together. But I'll take -2 plus 4 divided by 2. And that -2 plus 4 is equal to a +2 divided by 2 is equal to 1. Okay, now let's look at the y's. -2 plus 0 over 2. -2 plus 0 is -2 over 2. And -2 divided by 2 is 1. Okay? If you want to have this in better notation, you can. Okay, but the midpoint is 1, 1. Now let's plot this, make sure it looks like it's about right, which it doesn't because it's to be -1. My mistake. Okay, so 1, -1 is right here, which looks to be about where the midpoint is. Okay, that's how you find the midpoint, the average of the x's and the average of the y's. Let's move to the distance formula in the coordinate plane. Now this is from the Pythagorean theorem, which you should have learned about in previous math classes. Maybe not last year, but previously you should know about the Pythagorean theorem, that a squared plus b squared is equal to c squared. And that's true for any right triangle. We'll come back and look at that more later on this year, but we'll use it right now to find the distance formula. Now I'm going to solve this formula for c. So the first thing I'll do, I'm going to rewrite this as c squared is equal to a squared plus b squared. Okay, just so it's easier for me to solve for c. But I've not done nothing besides kind of flipping the equation around. Now the way I find c is by doing the opposite of squaring. Okay, so the opposite of squaring is by taking the square root. So I'll take the square root of both sides of my equation, and c is equal to the square root of a squared plus b squared. Okay, now keep that in mind because it's important to us, where a is the change in x's and b is the change in y's. Okay, keep that idea in your mind. Let's move to the next picture. The distance between these points is the difference in the x's squared plus the difference in the y's squared, and you take the square root of all of that, okay? That's the same thing as we just saw here, except instead of a, we have x2 minus x1, the change in x's, and instead of for b here, we have y2 minus y1 in for b. Okay, hope you see the connection between those because the distance formula comes from the Pythagorean theorem. Let me give you an example of using this with these same 2 points, negative 2, 2, and 4, 0. Okay? In this equation, we're working with subtraction, and so the order does matter. I'm going to call this, just for easy, just for simplicity, I'll call this x1 and y1, and I'm going to call this x2 and y2. It's a good idea to label these points before you start until you get much more comfortable with this and can do this more in your head. Okay, but I'll label these points x1, y1, and x2, y2, and I'll just plug it into the formula. x2 is 4 minus x1 is negative 2 squared plus y2 is 0, y1 is negative 2. Okay, 4 minus negative 2. Now, if I'm subtracting a negative, it's the same as adding. So 4 plus 2 is 6. And 0 minus a negative, again, I'm subtracting a negative, which is the same as adding. So 0 plus 2 is 2. And 6 squared is 36. 2 squared is 4. So I have the square root of 40, and I will leave it just like that. Okay, I could find a decimal, or we'll talk about later on in this year how to simplify square roots, but we'll get to that later on this year. But that's good enough for now in finding the distance between these 2 points. Okay, this video was about finding midpoints and distance in the coordinate plane.